Good morning. The topic of my presentation today is partial veneer crowns. Partial veneer crown is generally a more conservative restoration requiring less destruction of tooth structure. Its use is based on the simple tenet that sound tooth structure should not be needlessly removed. It also permits to evaluate the accuracy of fit at exposed margins. Cement can escape more easily, allowing more complete seating. Also, the uncut wall serves as a guide in reproducing natural contours in the restoration and makes pulp testing possible. Definition: a restoration that restores all but one coronal surface of a tooth, usually not covering the facial surface, according to GPT-8. The GPT-9 is called a partial veneer crown. A partial veneer crown is a restoration covering two or more surfaces of a tooth, according to Tillman. Then types of partial veneers. For anterior teeth, there are two types, three-quarter crowns and pin ledges. For posterior teeth, there are three types, three-quarter crown, modified three-quarter crown, and 7/8 crowns. Then indications for partial veneer crowns. Partial veneer crowns are a conservative measure and are preferable to the complete veneer crown. Intact or minimally restored teeth may require partial veneer crowns. Then teeth with crown length that is average or that exceeds the average. Teeth with normal anatomic crown form, that is without excessive cervical constriction. Then anterior teeth with adequate labiolingual thickness. No conflict between axial relationship of tooth and the proposed path of withdrawal of fixed partial denture. Then contraindications for partial veneer crowns. High caries rate, unprepared surface as well as increased margin is susceptible to caries. Then teeth with extensive restoration, as partial veneer crowns are preferred on sound teeth. Then deep cervical lesions, it is difficult to establish the finish line. If area is sensitive, complete coverage crown is indicated. Then teeth with short clinical crown, difficult to achieve resistance and retention form. Then thin teeth, as preparation of the retention grooves is difficult. And poor alignment of teeth in the dental arch. Endodontically treated teeth, and retainer for long span fixed partial dentures. Then advantages of partial veneer crowns. The tooth reduction is conservative. The aesthetics surpass the complete veneer cast crown. Margin accessibility for finishing and cleaning is improved. Complete seating of the casting is more easily verified. Complete seating of the casting during cementation is enhanced by diminished hydraulic pressure. Pulp testing can be conveniently accomplished on the intact enamel surface. The disadvantages of partial veneer crowns. The partial veneer crown is not as retentive as a complete veneer crown. Skillful preparation is critical. The partial veneer crown preparation is limited to fairly intact teeth with normally shaped crown and an average length clinical crown. There can be some display of metal and it requires high skill to hide the same. Then fundamental principles of design. The various principles are to impart strength to the remaining portion of the tooth crown, to provide maximum resistance and retention form to the finished restoration, to preserve aesthetics by conservation of tooth structure, thus limiting the display of metal on buccal and labial surfaces. And rotary instruments used for tooth preparations. One is round and tapered diamond, then torpedo diamond, short needle, long needle diamond, flame diamond, small wheel diamond, tapered fissure burr, that is 171L burr, then tapered fissure burrs 169L and 170L, then end cutting burr. Then steps for preparation of partial veneer crowns. The various steps include firstly the outline form, then the lingual reduction, incisal reduction, lingual axial reduction, proximal axial reduction, proximal box or groove placement, occlusal or incisal offset placement, then facial bevel, and finishing the preparation. Then 3/4 crowns. Maxillary posterior 3/4 crown. The 3/4 crown covers 3/4 of the gingival circumference of the tooth, leaving one surface intact. The facial surface commonly remains untouched. First of all, a putty index is made. This index is very helpful to judge the reduction for the preparation. It can be done in patient's mouth or on a lubricated diagnostic cast. As you can see in this picture, the putty index is formed on the tooth that is to be prepared, and then it is cut to visualize the anatomy of the tooth. And first of all, the first step is the occlusal reduction. Number 171 or round end tapered diamond is used. Depth orientation grooves are made on the triangular ridges and the developmental grooves 1 mm on the non-functional and 1.5 mm on the functional cusp. In maxillary, the lingual cusps are the functional cusp, whereas in mandibular, the buccal cusps are the functional cusp. Therefore, 1.5 mm of reduction is done on the lingual cusp of maxillary teeth and buccal cusp of mandibular teeth. Similarly, a non-functional cusp, 1 mm reduction is sufficient. Then is the functional cusp bevel. It should be parallel to the inward facing inclines of the cusps of the opposing tooth at a depth of 1.5 mm, creating 45-degree angle with the axial wall. It is made with a number 171 burr. You can see this picture. The functional cusp bevel is placed placed parallel to the inward facing inclines of the opposing tooth. Then is the lingual axial reduction. Torpedo diamond creating a definite chamfer all over is used for lingual axial reduction. Over inclination of the lingual wall frequently occurs. Check at all times for over inclination. The burr should be, to avoid over inclination, the burr should be oriented parallel to the long axis of the tooth. Then is the proximal reduction. Initially, thin needle diamond is used in sawing motion to just break the contact with the adjacent tooth. Once the contact is broken, torpedo diamond is used to create a definite chamfer finish line and complete the axial and proximal reduction. This is the needle diamond which is used initially to break the contact and create space for the torpedo diamond. Then the torpedo diamond is used to create chamfer finish line all over the axial surface. Then is the proximal groove. The groove is placed parallel to the incisal 2/3 of the facial surface. Orientation cut is made using number 170 burr with a depth of 1 mm or less. Then groove is continued apically to about 0.5 mm above the chamfer finish line. And grooves on mesial and distal side are made parallel to each other. As you can see in this, this is the proximal groove, and on the mesial, and this one on the distal side. It is made sure that these grooves are parallel to each other. This is the orientation of the burr while creating the proximal groove. Then is the proximal flare. Flame diamond and flame burr is used to produce the facial flares, that is a flat geometric plane. Okay. The groove is extended facially, creating a proximal flare. When the axis is good, a medium grit sandpaper disc may be used. This is the flame shape flame diamond, which is used to create the proximal flare, and this is the flame burr, flame diamond and flame burr. See, once the proximal groove is created, the facial wall of the groove is extended flat uh, along the facial surface. If the axis is good, the sandpaper grit can be used to create the proximal flare. Then is the occlusal offset. Number 171 burr is used to create a 1 mm ledge on the lingual incline of the facial cusp. This is the facial cusp and the its lingual incline. Now, this ledge is produced on the lingual incline of the facial cusp, connecting the grooves and assuming an inverted V shape. The proximal grooves on either side are connected with the help of a ledge, which is called as the occlusal offset. Now, number 957 end cutting burr is used to define the margins. This is the end cutting burr, and this one is the number 171 burr, which is used to create this offset. You can appreciate in this picture that a ledge is produced which is connecting the proximal grooves on either side. Now this is finished using the end cutting burr to make it more conspicuous. Next is the facial bevel. Now flame diamond is used to bevel the occlusofacial line angle, keeping it perpendicular to the path of insertion. The bevel should not be more than 0.5 millimeters wide. Okay. This is the flame diamond, which is used to create the facial bevel. Now, these are the features of the maxillary posterior 3/4 crown preparation. This is the, first of all, we had studied about the planar occlusal reduction, which provides structural durability, followed by the functional cusp bevel, which serves the same purpose. Then is the axial reduction, the lingual and the proximal axial reduction, creating a chamfer finish line. Then proximal grooves are placed, again, which provides retention and resistance and structural durability on either side, mesial as well as distal. Now, connecting these two grooves is the occlusal offset, which is a type of a ledge which is created on the lingual incline of the facial cusp. Then is your proximal flare, that is the extension of the proximal groove facially, creating a geometrical plane, flat geometrical plane. This is called as the proximal flare, which is required for marginal integrity. And finally, the facial bevel, which again provides marginal integrity. Now, the mandibular posterior 3/4 crown. Again, first of all, we will start with the occlusal reduction. Again, number 171 or torpedo diamond is used for occlusal reduction. And depth orientation grooves are made on the triangular ridges and the developmental grooves, 1 millimeters on the non-functional cusp, that is the buccal cusp, that non-functional cusp, that is the lingual cusp of the mandibular posterior, and 1.5 mm on the functional cusp. Functional cusp is the buccal cusp. Then, or at the occlusofacial line angle, groove is made only 0.5 mm deep to minimize the display of metal. Then tooth structure from between the grooves is removed according to the cuspal contours. The next is the functional cusp bevel. A round and tapered diamond is used to create the functional cusp bevel. 1.5 mm deep grooves are placed on the facio-occlusal line angle. Number 171 burr is used to plane the area between the grooves and finish the functional cusp bevel. Next is the occlusal shoulder. Number 171 burr is used to form the occlusal shoulder along the termination line of the functional cusp bevel facially. Where the functional cusp bevel ends, at that point, the occlusal shoulder is created. End cutting burr is used to plane the shoulder at least 1 mm wide. So number 171 burr is used to create a shoulder finish line, and end cutting burr is used to finish the shoulder. See, as you can see, this burr is used. Number 171 burr is used where the functional cusp bevel is ending. This burr is used to create the shoulder finish line, that is the occlusal shoulder, and end cutting burr is used to define the shoulder. There is the lingual axial reduction. Torpedo diamond, creating a definite chamfer all over. Over inclination of the lingual wall frequently occurs. Then torpedo diamond is used to create a chamfer finish line all over the lingual axial surface, and over inclination should be checked at all times. Then is the proximal reduction. Initially, thin needle diamond is used in sawing motion to just break the contact with the adjacent tooth. This is the needle diamond which is used in sawing motion to break the contact with the adjacent tooth. Now, once the contact is broken, torpedo diamond is used to create a definite chamfer finish line and complete the axial and proximal reduction. Then is the axial finishing. Torpedo burr is used to produce a distinct finish line and round off the angles of the preparation. Then proximal groove. It is placed parallel to the incisal two-thirds of the facial surface. Orientation cut is made using number 170 burr depth with a depth of 1.5 mm or less. Groove is continued apically to about 0.5 mm above the chamfer finish line. Grooves on mesial and distal side are made parallel to each other. As we had seen in the previous preparation, these proximal grooves are always made parallel to each other, and they are about 1 mm deep. As you can see, this burr is used to create the proximal grooves on either side, and you can see the parallelism between the grooves. Then is the proximal flares. Flame diamond and flame burr is used to produce the facial flares, that is a flat geometric plane. When access is good, a medium grit sandpaper disc may be used. The flare is wider at occlusal than at the gingival with a definite finish line. Then is the facial bevel. Flame diamond and number 170 burr is used to bevel the occlusal shoulder. Wherever the occlusal shoulder is formed, a bevel is placed with the help of a flame diamond or number 170 burr. That is the facial bevel. And these are the features of the mandibular posterior three-quarter crowns. First of all, the planar occlusal reduction providing structural durability. followed by the functional cusp bevel, which again provides structural durability. Then the occlusal shoulder, where this functional cusp bevel ends, occlusal shoulder is formed using the number 170 burr. Then the proximal and then the axial reduction. The lingual and the proximal axial reduction is done, creating a chamfer finish line. Then proximal grooves are placed on either side, that is the mesial and the distal side of the tooth, parallel to each other, providing retention and resistance and as well as structural durability. Then the proximal flare is formed, that is the flat geometric plane on the facial surface, and the occlusal shoulder is finally beveled, which is the facial bevel, which forms the facial bevel. So these are all the features of the mandibular posterior three-quarter crowns. Next is the anterior three-quarter crown. The anterior three-quarter crown preparation is mostly similar to the three-quarter crowns we had discussed earlier. First of all, the incisal reduction is done. Okay, the lingual only on the lingual incline of the incisal edge is prepared. Then the axial reduction is done, creating a chamfer finish line. Then lingual reduction is done with the help of a small wheel diamond. Then proximal grooves are created on either side, that is the mesial and the distal side, providing retention and resistance as well as structural durability. Then connecting these two grooves is the incisal offset, just like the occlusal offset, which is the ledge connecting the two grooves. Then incisal bevel is placed on the lingual incline. Then this is the flare, which is which is prepared on the which is the proximal flare, that is a flat geometric plane. The facial wall of the groove is extended facially to create this flare. And the features of the pin modified three-quarter crown preparations. Most of the preparation is the same. Only thing is that we have to, first of all, the axial reduction is done on the lingual side as well as the proximal surface, creating a chamfer finish line. Then the proximal grooves are created. The flares are created. Now this is the incisal offset, which is connecting the two grooves. Then this incisal bevel. Then for the pinhole, the ledge and pinholes are created for retention and resistance. This is the lingual reduction. Then is the maxillary posterior 7/8 crown. Okay, in the first step is the occlusal reduction, which is done with number 171 burr or torpedo diamond. And depth orientation grooves are made on the triangular ridges and the developmental grooves, 1 millimeter on the non-functional and 1.5 millimeter on the functional cusp. At the occlusofacial line angle, groove is made only 0.5 mm deep to minimize the display of metal. The tooth structure from between the grooves is removed according to the cuspal contours. As you can see, this burr is used to create the depth orientation grooves along the triangular ridges and the developmental grooves, and the tooth structure which is remaining between these grooves is removed following the cuspal contours to complete the occlusal reduction. This is the side view. This is the depth of the orientation groove. This is the picture showing the complete occlusal reduction. Then is the functional cusp bevel. It is done using round and tapered diamond and number 171 burr. Depth orientation grooves are placed across the lingual inclines of the lingual cusps. Then the bevel should parallel the inward facing inclines of the opposing tooth at a depth of 1.5 millimeter, usually forming a 45-degree angle with the axial wall. And you can see in this, this burr is inclined at an angle of 45 degree to the functional cusp, and 1.5 mm deep groove is created. Now this groove is made flat, creating the functional cusp bevel. Then facial and lingual axial reduction. It is done with the torpedo diamond producing a definite chamfer finish line at the same time. The lingual reduction is carried as far as possible into the interproximal embrasures without nicking the adjacent teeth. The distoaxial reduction should end 1 millimeter mesial to the facial groove. See, this is the lingual reduction, which should be carried as far as possible into the interproximal embrasures. Now, the distoaxial reduction should end 1 mm mesial to the facial groove. Okay, this is the facial groove is formed. So, the distoaxial reduction should not extend beyond 1 millimeter to the facial groove. Then the proximal axial reduction. A short, thin, tapered diamond is placed against the lingual surface of the remaining interproximal tooth structure, and a sawing motion is used. See, this is the short needle diamond, which is used to complete the proximal axial reduction. It is used in a sawing motion, and it is continued towards the facial surface until contact with the adjacent teeth is barely broken. Okay. Now, once sufficient space has been produced, a torpedo diamond is used for axial reduction and to produce a chamfer finish line. Okay, it should just barely break the contact with the adjacent tooth, and room is created with the help of this burr for the torpedo diamond to enter into this interproximal embrasure area. Now, once sufficient space is created, then torpedo diamond is introduced, and the axial reduction is completed, creating a chamfer finish line. Then is the axial finishing. Torpedo burr is used to produce a distinct finish line and round off the angles of the preparation. Then grooves. Number 171 burr is used to prepare a mesial and a facial groove correctly aligned with the path of insertion. In 7/8 crown, there are two grooves which are made. One is the facial and the other one is the mesial groove. 7/8 crown mein only the mesio-buccal cusp of the tooth remains intact. So a facial groove is placed and a mesial groove is placed along with along the path of insertion. Then flares. A flame diamond and carbide burr is used to make the mesial and facial flares, which are narrow at the gingival end and wider occlusally. You can see this. This is a flame diamond. Flame diamond, which is used to make the mesial and the facial flares. That is the occlusal offset. Number 171 burr is used to produce a 1 mm wide ledge on the lingual incline of the facial cusp, connecting the grooves. These are the grooves. This one is the facial, and here must be the mesial groove, assuming the shape of an inverted V. Now its floor is perpendicular to the path of insertion. Then occlusal finishing level, a flame diamond or number 170 burr is used for creating an occlusofacial finishing bevel. The bevel is rounded up to the proximal occlusal line angle to blend with the proximal flares. Now this is the bevel which is created. This is rounded up to the proximal occlusal line angle to blend with the proximal flares. Now this is the this is how the preparation will look from the occlusal view. You can see this mesiobuccal cusp remaining intact, and two grooves are placed. This one is the facial groove, and this one is the mesial groove with the mesial flare and the facial flare. And connecting these two is the occlusal shoulder and the bevel. And this is the definite chamfer finish line which can be seen all over the axial tooth surface. Now these are the features of the 7/8 crown preparation. You can see this. First is your planar occlusal reduction, providing structural durability. Then the functional cusp bevel. This is the axial reduction, the lingual and the proximal axial reduction, creating a chamfer finish line. Then is your facial groove, the facial flare, the mesial groove. Then connecting these two grooves is the occlusal offset and the occlusal bevel on the lingual incline of the facial cusp. So this is the 7/8 crown preparation. Then is the proximal half crowns. Now, first of all, again, the first step is the occlusal reduction, which is done with round end tapered diamond and number 170 burr. Depth orientation grooves are placed on the distal aspect of the occlusal surface. The distal aspect of the occlusal surface 1.5 mm deep. Since the mesial segment of the tooth is dropped below the occlusal plane, is dropped below the occlusal plane, the grooves may not be as deep. Okay, this is the depth orientation groove just placed on the distal aspect of the occlusal surface. The grooves are not as deep on the mesial part as on the distal. This proximal half crown is usually given in cases where there is severe mesial inclination. So already the tooth is inclined mesially. That is why the mesial surface is below the occlusal plane. Then the tooth structures between the orientation grooves are removed following the cuspal contours. As we have seen in earlier preparations, the depth orientation grooves are made 1.5 mm on the functional cusp and 1 mm on the non-functional cusp along the triangular ridges and the developmental grooves. Now, once this is done, the tooth structure between between these grooves is removed following the cuspal contours to complete the occlusal reduction. Then is the next is your functional cusp bevel. It is done using round end tapered diamond and number 170 burr. Depth orientation grooves are placed across the facial occlusal line angle of the mandibular molar. The bevel will be shorter and shallower on the mesial cusp than on the distal. The functional cusp bevel, as we have discussed earlier, is placed on the functional cusp, that is the buccal cusp of the mandibular teeth. That is why it is placed on the facio-occlusal line angle. But this bevel should be shorter and shallower on the mesial aspect of the tooth as compared to the distal aspect. Then the mesial axial reduction. Torpedo diamond is used for the axial reduction by making the path of insertion of the mesial surface parallel with the long axis of the premolar abutment. Now this is the premolar abutment and this is the long axis. Now the mesial reduction should be done such that the long axis of the mesial surface parallels the long axis of the premolar. Then the end of the diamond will eventually make contact with the tooth in the gingival area of the mesial surface and produce a chamfer finish line. Then facial and lingual axial reduction. It is done with a torpedo diamond, producing a definite chamfer finish line at the same time. See, this burr is used again paralleling the long axis of the premolar abutment, and a definite finish line, chamfer finish line is created. Now end the extension 1 millimeter or more mesial to the distofacial embrasure. Now this is the distofacial embrasure. Your preparation should end 1 mm or more mesial to this distofacial embrasure. Now this distance should be 1 millimeter or more. Axial finishing. Torpedo burr is used to produce a distinct finish line and round off the angles of the preparation. Then occlusal isthmus and countersink. Number 171 burr is used to make an occlusal isthmus and a countersink in the distal fossa to supplement retention, resistance, and structural durability. So this is the occlusal isthmus and the countersink. You can see in this, this burr is used to create the occlusal isthmus and the countersink. Then facial and lingual grooves. Number 171 burr is used to make parallel grooves on the facial and lingual surfaces within 1 millimeter of the vertical distal extension of the preparation. Now there are two grooves which are made, one on the facial surface and another on the lingual surface, but it should end at least within 1 millimeter of the vertical extension or distal extension of the preparation. The groove should be parallel to the mesial surface of the tooth and the long axis of the other abutment. Okay, this is the mesial surface. Now these grooves should parallel both the mesial surface of the tooth as well as the long axis of the other abutment. Now this is the facial and the lingual grooves. Now the distal occlusal offset, a V-shaped offset 0.5 to 1 millimeter from the distal occlusal finish line, connecting the lingual groove to the countersink to the facial groove is made using number 171 burr. There's a V-shaped offset which is formed. This is the distal occlusal finish line. The lingual groove is connected to the countersink and to the facial groove using this. Using 171 burr, and this is called as the distal occlusal offset. This is the distal occlusal offset. The lingual groove, the countersink, and the facial groove are both three of them are connected with each other through the distal occlusal offset. Then flares and occlusal bevel. A flame diamond is used to place flares distal to the facial and lingual grooves. In this case, the flares are placed on the distal aspect of the facial and the lingual grooves. And occlusal bevel, a bevel is cut along the distal marginal ridge with the flame diamond, taking care not to extend into the distal occlusal embrasure. This is the bevel which is formed and is called as the occlusal bevel. Okay, but care should be taken not to extend into the disto-occlusal embrasure, this area. Now, these are the features of the proximal half crown preparation. Here we can see, first of all, we had started with the planar occlusal reduction, providing structural durability. Then is the axial reduction, the lingual and the proximal axial reduction, creating a chamfer finish line. Then this is the groove which is created within 1 millimeter of the vertical extension of the distal part of the tooth. This is the lingual and the proximal, lingual and the facial groove which is formed. Then connecting these two grooves is the occlusal offset. This is the countersink, which is isthmus and the occlusal isthmus and the countersink which is created. And connecting this is the occlusal offset, and the occlusal bevel is formed on the distofacial occlusal surface. These are all the features of the proximal half crown preparation. Thank you.